topic of stoichiometry, slowly but surely. And today we'll be looking at percent composition. And percent composition is a very, very nice, simple concept, but as I always say, very important. For example, a lot of industries and businesses use percent composition in their products. So for example, food products, you need to know the percent composition of different substances that are in there, right? For you, maybe for health purposes and so on, right? So, percent composition is important. Also, it helps, right, later on when we do concentration, if you're doing percent by volume, you're gonna have an understanding and a foundation of how to set that up when we do percent composition by mass. The nice thing about it is found on the reference table, so we always have our reference tables and we always have our calculators, right? Anytime we're doing math and chemistry, important tools. So always have those guys. Okay, so let's do a simple example. So let's say we have glucose, right? Which is C6H12O6, right? And you can be asked, right, to find the percent composition of mass by any of these elements in the compound glucose. For example, you could be asked to find the percent composition by mass of carbon, or hydrogen, or oxygen. Sometimes you could be asked to find the percent composition by mass of all three, all right? But typically on an exam or something, they just ask you one of those guys, okay? So here's what you do. Anytime they ask you to find percent composition by mass, you simply look on your reference table, table T, and you see the formula, right? That percent composition, right? Okay, is equal to the mass of part, okay, over the mass of the whole. Okay, alrighty. So guys, the mass of the whole is essentially the same thing as calculating the GFM, the gram formula mass, or the mass of the formula in grams. We did that before, previously in class, right? So let's make a note of that. So once again, chemistry being foundational, you know how to calculate GFM. That's how you get the mass of the whole, right? And the mass of the part, right? The mass of the part is just taking whichever element out of the whole and putting it on top. Okay, so let's do the example. So let's say we're finding the percent composition by mass of carbon, right, in glucose. So we see that we have 6 carbons, okay? Each of them is a mass of 12.0. Now once again, guys, you have your reference tables. Over time, I've remembered some of these guys' elements masses. If you don't remember them, as I said before, no shame, look at your reference table, no problem. Hydrogen, right? We have 12 of them, all right, 12 there, and each of them has a mass of 1.0, okay? Oxygens, we got 6 of them, and each of those have a mass of 16, all right? Okay, so we're gonna have 72, 12, and 96 as our masses, right? And we're gonna add those up. So what are we doing right now? We are getting the mass of the whole in our for our equation right there, no problem. So we're gonna add these guys up. So that's gonna be 0, 6 and 2, 8 and 2, 10. It's another 0, we carry the 1, 10, 11, 18. Okay, so that's 180. So we successfully calculated, right, the mass of the whole, the mass of this glucose right here. Alrighty, now that will go in the bottom. So it's going to put it in the bottom. Percent composition, right? Now we're doing it for carbon. It's going to be equal to whatever goes on top over 180. Now the thing is that sometimes this mistake students make, right? They say, okay, since it's carbon, I'm going to put carbon up here. The mass of carbon is 12, and I put it up there, right? But you have to make sure, guys, that you put the correct number of carbons and its mass up there. So we got 6 carbons, each of them being 12. So don't just put 12 up there because the question said carbon. You have to represent for all the carbon in the compound. So it's 6 times 12, 72 goes on top. Okay? So that's 72. Okay? Alrighty. So what you do next? You're going to multiply that by 100. All right, and that's going to be your answer. All right, so there we just go. 6 goes into 72 what? 12 times 6 goes into 180, what's that, 30? Okay, what else I can do? 6, that's 2, 6, that's 5, okay. 5 into 100, that's 20, okay. 2 times 20 is 40, okay. So 40 is our answer, 40% of carbon, and you're done. Alrighty? No problem. So that's a nice simple example, guys, of percent composition. Alright, so all this example encompasses all, you know, the ways you do it, right? Simple, there's no other got you. Follow the formula, you put the correct number of the element and its mass on top. The GFM basically goes on the bottom, and you're done. Now I just want to talk about 2 other things before we wrap it up. Alrighty, let's go for a cleaner page. There we go. Alrighty. Let's see. Let's say they give you a question like this. You have 400 grams of glucose, right? C6H12O6, right? And they asked you how many grams of oxygen, right, are in this 400 gram sample of glucose. How do you figure it out? We use what we had before, right? Our percent composition. So what's going to happen is this. We know from experience, right, that percent comp, okay, for oxygen is going to be equal to the mass of the part, okay, alrighty, over the mass of the whole, alright, times 100. Okay, this is our standard equation from table T, right? So what do? We know from previously, right, that the mass of the whole is going to be 180. We know that we have 6 oxygens. 6 times 16 is 96. All right, that goes on top. We're going to multiply that by 100. Okay? Alrighty. So let's see if we can reduce this up. So this, like 6 into that is 30, and 6 into that is 16. Okay, let me see. 2, I got 8, 2, I got 15. So I got 8 over 15 times 100. Alrighty. Okay, 8 divided by 15. I'm going to times that by 100. Bam. So I got 53%, 53.3%. Alright, so 53.3% is our answer. No problem. Now, that's not our final answer. That's our percentage of oxygen. Now, what we want to do, right, we want to find out how much, in terms of grams of oxygen, is in this sample. So what we're going to do, we're going to use this guy right here, our percentage right here for oxygen, in relation to the 400 gram sample. Now, remember, guys, percentage, right, is simply what? It's simply some number over 100, right? So we could either convert this to a decimal by moving it 2 places to the left, or we could use it like this. So you have a choice. You got 400 grams times 53.3 over 100, or you can say 400 times 0.12 places, 0.533. Either or, you should get a correct answer. So let's do the second one, no problem. So you got 400 times 0.533 equals 213.2, okay? So what we just did, we just calculated, right, the mass of oxygen that will be in this amount of glucose, 400 grams of glucose, using and taking advantage of percent composition. All right, guys, as always, hard work with sacrifice equals success. Percent composition is very important. The form is on the back of your reference table. Make sure you have your calculators, make sure you have your reference tables with you, and you're good to go. All right, take care.